whereas tutorials with respect to people, more of hands-on sessions is what we're looking at. I think just to summarize, I think we will look at how to simply deploy a hello world application in GKE. Then we took a next level where how to deploy the last session we looked at how to deploy a multi-tier web application, which will have a front end and also a back end. And back end being Redis and the front end being a PHP web application as a simple guestbook. And so we try to give some inputs from the UI and also it stores the data in Redis and all this deployed on a Kubernetes cluster. So that is something that we saw in the last session. And today we're going to see how to use persistent storage. I mean, assuming that you have a DB, a proper DB. In the Redis case, it was more. It is not a DB. It is just a in-memory database. So in-memory database is like Redis. If you restart, the data is gone. So, but the scenarios will also need a lot of DBs. In most of the applications, we need a DB. So if we are using a DB, so we need to store the contents from the DB. So that's where we need disk so the disk storage is required. So today we're going to see how to set up a volume. There's something called volume that we need to know. So how to set up a volume, and volume is like amount that you create on a virtual machine. So you can imagine volume is like an external hard disk if you have to compare. So assuming that you have an external hard disk, and laptop is your node. So it is very well possible to copy the contents from your laptop. So copy the content from your laptop to hard disk, and you can, let's say if your laptop is crashed, you still have the data in the hard disk. You can associate that hard disk to some other laptop also. The similar concept. Assuming your DB is the files that are required to store in a DB. Let's use it is using the data is all stored in the hard disk. So the hard disk is more safer compared to even if the laptop crashes, hard disk data is still safe. So yeah, it's a similar concept where we use volumes in Kubernetes, where the DB stuff is all stored in volumes, and in case if the node crashes, or pod crashes, still we have the data persisted, so that we don't lose the data. So that is the concept. It's a bit advanced concept, but I think it's a very common scenario in a common use cases like web applications, right? So the DB is a very common scenario. So so that's what we're going to see today. So in this, the Kubernetes objects that we are going to introduce newly are, I think last session, so we just briefed about it. So today we are going to see the new Kubernetes objects called volumes, which is like PersistentVolumes. PersistentVolumes and PersistentClaims. So these are two things that we're going to see in this Kubernetes objects. So let's continue with this. Yeah, so this is the one. So deploying the WordPress. So basically WordPress is a simple, like WordPress is a blog, right? You might be knowing it. So just sample websites where you can build using WordPress. So this generally WordPress, I'm just talking about generally WordPress is an open source setup of website building platform. So this website building. So this website building, since it is an open source website building, so it will have a UI component, and also it will have a backend component, and the backend is MySQL, and the UI is PHP. I guess. 1 minute. could see, right? You could see my screen. Hello, guys.
Yes, Shyam, I'm able to see your screen.
Okay, okay.
Yes, Shyam.
Okay. Sorry. So Shiva is from office. He just connected, but I think he got disconnected. So yeah, Let's sorry for that. Yeah. So we are looking at this PHP. So generally, website building will have a UI component and backend component. So yeah, we're going to deploy a UI component and also a backend component. And in this MySQL, which is a backend component, so for in GCP, what we're going to do, we are going to use the GCP resources for the backend MySQL. We're going to use Cloud SQL. Cloud SQL is a managed MySQL from GCP. So we're going to use this, and also we have to store this data, right? So of course here also we need storage, which so generally it could be any storage. So here we are going to use a disk storage. So because we need to store the content in a disk, a hard disk. So hard disk is also used. So here for the storage, disk storage, which is a disk storage, we are going to use a GCP component, which is persistent volume. Persistent disk. Persistent disk is a product within GCP, which is giving you the disk, like hard disk. It's a product name. I mean, just that you need to know the product name within GCP. So yeah, so the summary is MySQL and disk storage is our requirements, and we are using GCP product, which is Cloud SQL, and persistent disk. These are two things that we're going to use now. Okay, so with that background, let's proceed. So I just made some quick notes for your reference. So we're going to deploy this WordPress on GKE with persistent disk. Of course, we are going to set up a single replica WordPress deployment on GKE. I think we just discussed with MySQL as a database. Instead of installing MySQL, we are using a Cloud SQL, which is a managed MySQL from Google. So, I mean, for us, it is just we need to know that it is a MySQL on Google. So that's all. So, and of course, WordPress uses persistent volumes and persistent volume claims to store the data. So, again, why we need volumes? Again, the background is in a Kubernetes world, even a MySQL is also a pod. Okay, so a pod can die down for whatever reasons. So a pod can die down. So which means a MySQL also can die down. So when something is dying down, so we need to store the state. That is very specific to my database. We need to store the state of the database somewhere before, so that the next one, when it is up, it can take it from there. So we need to store the volume somewhere. So that's where the container's root file system is generally used. Root file system is where every container will have a root file system. That's where we generally store stuff. But when the container itself is dying away, it doesn't make sense to rely on this root file system. So we need to store it somewhere in a persistent storage medium. That's where we are going to use the persistent disk here. So which means we are going to store the data in a disk. So imagine that it is like a hard disk. So you're storing this state in a hard disk. So when your laptop dies, when the node dies, all the data is saved and the data is not lost. So that is the background. So that's where we need volumes. That's why it's called in Kubernetes terminology, it is persistent volumes and persistent volume claims. So the solution for this is persistent volumes. We will use this to back up the state in storage types like disk. So with this, any questions before we get into this? Okay. So let's go to the practicals. So at a series of objectives, this is what we're going to do. So we're going to create a GKE cluster. We also going to create a Persistent Volume and a Persistent Volume claim backed by Persistent Disk. And also we're going to create a Cloud SQL for a MySQL instance. We're going to deploy the WordPress and set up the WordPress blog. So these are things that we're going to see. So as part of this process, so of course we're going to use the Google resources like GKE, of course, for Kubernetes purposes. Compute engine. This is, of course, the nodes are all virtual machines. So virtual machines in GCP is called as compute engine, and MySQL is Cloud SQL in GCP. So these are things that we're going to use from GCP end, so these are all things which these are all just general stuff where you need to get access to GCP and you need to have an account and all those stuff. I think we already have all those things. So let's directly move to the environment setup. So with this, let's connect to GCP. So this is GCP, and if you see this Kubernetes cluster, I deleted it last time whatever we created because it computer cost. So at this point it's empty. Don't have any cluster setup. So we need to start from scratch, more or less. So what I did is I just click this console, which is already running here. The Google Cloud Shell Editor. So here we can start using the commands. So let's get into the steps. Because the Google Cloud the initial thing is first you need to set up the compute zone. So get the steps ready here. So I'm just setting the compute zone. Compute zone could be anything like US. There are a lot of regions that you could set. US West, US East. So I'm selecting US West, but even you can select, for example, Asia, Singapore, or India, whatever. So I'm just selecting US as my zone. These are all G-Cloud specific configuration. I think Kubernetes specific. These are all G-Cloud specific. So of course here I'm setting export the project ID and setting it to project. Project ID is something that we're going to use in the code. Project ID is something that you will also get here. This project ID is Steam Spider. So this is what it's already set here, but I'm just resetting it once again. So that in further you can use $project ID so that this can be accessed. Now, of course, all our code is all available in GitHub as well. So of course you can also go and check. Here I have a lot of samples from GCP. All the Kubernetes engine samples are all available here in GitHub. So in this is what we are looking at the last couple of sessions. But here you have the source code for this. All the source code for this exercise is all copied here. So it's already available here. So we are trying this WordPress persistent test. I think I did the Git clone already here. So you already have it here. Persistent test. So these are the files that we have here. So if you go here, mostly you will see YAML files here. So we're going to see that by YAML files only now. Let's move on. So far we are here. Git clone CD, goes CD to this folder. Let's do that. I already git cloned here, so I'm not using that command again. I'm already git clone stuff. I already did that, so it's already here in this place. CD to WordPress Kubernetes. I'm already in that location, so I'm not doing this command. So setting the working directory. Okay. So with that, we all did all the configuration required in console. Basically, we had set the cloud, the shell config, telling what zone, whatever command that is going to execute, there should be executed on which zone, and we also set the project ID so that all this there will be multiple projects will be there in GCP. So I want to set up all these resources on this project at Steam Spider. So that's why I said that, and of course I set the working directory as a current directory. So So with that, this is where we are actually now going to the creating the cluster setup. So let's create a cluster. Um, so here, if you look at the cluster command is gcloud container cluster create. So this is the command. It is, of course, you can do it from UI. Go here and create, and you can create the cluster like this also. But if you want to do the same thing from command line, you can do that using command line also. So we are going to use the command line approach. So let's move to the command line approach where at this point it's going to create a cluster with this cluster name. Cluster name is persistent tutorial, and the nodes we are telling us we need 3 nodes, and enable auto upgrade, and also we are adding some additional parameters in this process. Of course, you can just give these. This is the basic thing that it is needed. These are all additional stuff, which are optional. But it is here in this case we are enabling some additional parameters. Enable auto upgrade, meaning upgrade to the nodes. So if any patches are there to the nodes, it will auto upgrade. And no enable basic auth. We are basic authentication we are not enabling. And also no issue client certificates. So generally the client certificate is issued by default so that the nodes are secured. So we are asking not to do that. And also enable IP alias. The IP alias we're asking to enable it so that we can access those with IP names, with alias names, the nodes. And also of course the metadata we're asking to print, and also disable legacy endpoints if you can do true. These are the parameters that we are asking to set while we're creating the cluster. So in this process, there will be a master node that will be created, and there will be 3 worker nodes that will be created. So let's run this command. This will take some time anyway. Yeah, so at this point it is trying to create then create a Kubernetes cluster with this name. So yeah, it takes at least a couple of minutes while it is running. So of course, we can come here and do it from here also. But we can also, this is a command line, you can also see here. You can see this details in the command line. So if you use this, again, same command, gcloud beta container create. So this is container create. So this same command is what we are also using here. So closing it. So anyway, so this is the command while it is running. So the next steps would be, here if you see here, we need to, the zone is very important here. I mean, all the nodes that are getting created here, this zone is what the zone that we asked, where we default is configured. So basically all these 3 virtual machines that is going to create as nodes, so they all will be configured in the zone that we created earlier. So this is a zone, for example, zone we set to US is. So yeah, so we're going to create that. So where it is creating, let's also look at the structure. So for PVC. So yeah, at the end of this, this will going to create some Kubernetes cluster with a master and 3 nodes running. Now we can start. So now Kubernetes cluster is ready. So now from here on, we are actually executing the Kubernetes commands. Right. So this is Kubernetes specific now. So what we are going to do is we are planning to request a disk for Kubernetes. Because we just like external hard disk that we're talking about, right? So we need to first procure the external hard disk. So that is what the first step that from Kubernetes we're going to request a hard disk of 200 GB. So that we get a 200 GB external hard disk ready. So for that you need to create a request. So that is request is what is called as PVC, Persistent Volume Claim. So create a PVC as a storage required for WordPress. GKE has a default storage class resource installed, and that lets you to dynamically provision the persistent volumes backed by persistent disk. So let's look at this PVC WordPress volume claim.yaml file. So this is the WordPress volume claim.yaml file. So it's a simple steps, so nothing complex. So here, the important thing that we need to see here is the kind. Kind here is persistent volume claim. And of course, everything have an API version and metadata, so which will uniquely identify this. The spec is what is important. The spec here we're telling, say Kubernetes, I need an access mode where I could write some data, write data to this volume, and also I'm asking what is my request limit, like storage limit. I'm telling 200 GI. GI and GP is, I mean, we know 200 GB, right? GI is like gigabit. Gigabit is like, the difference is giga versus gigi is, yeah, this into 1204. And generally we know GP is equal to, not GB, I mean, one byte is equal to 1024, I mean, 1000, for example, 1000 bytes, 1000 bits, sorry. But here GI probably, right? So this is equal to 1024. 1024 is what is considered. For example, 200 GI is GB is equal to 200 into 1000 bytes. So that is the space that you get. 200 GI is 200 into 1024. Right. So which means your difference is, yeah, this is you'll get this is more bigger size than GB, for example. That's what I'm trying to say. So GI is what we're setting this. So let's see, this is created. This got created. So now we have a Kubernetes cluster is created. The name Persistent tutorial is West E. West 1 is the location, and this is the master version of the master. Master GK Kubernetes version is 1.18, and master IP is this. Size of the virtual machine is E2 medium. And of course, the node is a worker node. So worker nodes and master nodes are all same, 1.18. And nodes are created are free and status is running. So you can also see the same thing from the UI as well. So if I go here in the UI, you should be able to see. Earlier it was no records where there is an empty screen, but now you should see this persistent volume cluster that got created now. So this is the first time seeing this error. Okay, no, that's okay. It's very slow today. Let's come to this. So yeah, we're going to run this. This YAML file, so that we are basically at this point we are requesting, we're putting a claim saying that I need 200 GB. So it is actually here we're putting just a request. It doesn't execute yet. So it is at this point we're putting a request. Some problem. So I think we come from command line, we know it is already created. So let's proceed with the steps. So yeah, so now we are going to request this manifest file will describe PVC that requires 200 GB of storage. A storage class has not been defined in the file, so the PVC uses a default storage class. So here it also uses a storage class which is not defined here. So generally storage class is also one of the parameter. If it, but again the spec section will have storage class. but here we are not giving storage class, which means that it can, it will by default use the GK is the storage class, which in this case it is persistent volume. So it uses that. So let's run this command and this process. So I'm running this persistent volume claim YAML. So it got created. So if I just run this kubectl get pb. So PVR you can also shortcut as things of PVC. So yeah, it is telling you that if you have requested this requirement, no status is bound, which means it is just accepted your request. So volume ID is this 200 GI. Read write access mode we had set to or read write once or the 0 and standard storage class and 79. This is a command that we executed now. So let's yeah, process is complete and output looks on. Okay. Now so that's now created a volume claim. So now let's go to the DB side. We will first create a DB because we need a MySQL DB. So I mean these steps are nothing to do with Kubernetes. Basically we are setting up a simple MySQL DB in GCP. If you look at all these commands are gcloud commands, not kubectl commands. So there is nothing much to know from Kubernetes side, but I'm just quickly executing the steps. So it is actually it is going to create a DB for you in the background at that run, and also they're asking to create a connection name as an environmental variable. I mean, these are all steps that you should follow for creating a MySQL DB in cloud. I mean, here it is GCP, but I think the steps more or less will be similar in any cloud when you want to create a DB. So probably the syntax might vary here and there, but conceptually the steps would be same. So you're going to create a DB requirement. So here in Google we use gcloud SQL. So that is a command line for DB operations. So here we're asking to create a DB, which is an instance named MySQL WordPress instance. So we're going to create that, and also we're exporting that instance connection name as an environmental variable, so that going forward you can use dollar of this, you get the connection name. So this process to get the connection name, again we're using another dollar here. Describe command is what we're using, which is actually displaying and in that actually we are looking for the connection name. So by default it creates a connection name, and we're assigning that connection name to this by using this describe command. Okay. So let that it is creating the DB in the background. So let's see UI side impact. Okay, now see here the UI created this Kubernetes cluster. Persistent tutorial is the name with 3 nodes. So and so we have a cluster created with the 3 nodes, and the node names are these. For example, the 3 nodes are there, equal medium size. And the 3 nodes are nothing but a virtual machine. So we are having 3 virtual machines created, and now the DBs that we're creating, so could be installed in any of these volumes. So and also the resources that we're going to create will be used will be deployed in this at the nodes. Let's come to that. So yeah, it's still creating. This will take some time. Well, and let's proceed with the other steps. So after it will create the connection name, and then after that we are going to create a database for WordPress. So I mean, at this point you created the database, installed the DB. The next third step is to create a database. So basically installation is done. MySQL installation is done. Now you are opening MySQL installation. And you are creating a database inside the MySQL. So the database name is WordPress, and also the database. Once you create a DB, this other general steps are you will create a user ID and password. so it could use a user ID and password to connect. So you need to create a user ID and password. So that's what the gcloud users command, SQL users command will be used. SQL DB. And if you look at log into the gcloud SQL instances create, then instances describe, then SQL databases create, then SQL users create. So these are the steps. Once users are created, then we are done with the DB setup. So far, if you see, this is nothing to do with Kubernetes. This is all on GCE that we created it. So we have database ready running on GCP. Right. The next is the article steps is to deploy the DB. System is waiting. So next are steps to create a WordPress site. So here, while creating the WordPress site, the first immediate things which you need to take care. Again, this is common to now all clouds these days. You need to create service accounts. So service accounts are security standards that we need to follow. I mean, it is the recommended approach in cloud, in any cloud for that matter. So we are not supposed to use application user IDs like the olden days, where like if you're doing it on premise, you'll use your user ID and password. So generally, it's not a good practice to use that. We need to create an application specific user ID and password. And here, the application specific is here. It is now called a service account. So you need to create a service account, so service account are not tied to an individual. It is they're tied to a machine. So as long as the machine is gone, the service accounts are also deleted. So that is the advantage that you get, so that the possibility of someone hacking it is less. I mean, generally your individual user IDs will not be deleted. But if you create an application user ID, so when your instance is deleted, the service account is also deleted. So that's why the possibility of you forgetting to delete is less. So more security process. So yeah, you need to create a service account and create secrets. So in this process, we will first create a service account. First, you need to have instead of using your user ID, you need to first create a service ID, so with service account ID. So for that, you need to use IAM commands, IAM service account create. And then you can create a service account name called SQL proxy. And then you should set the email ID for this environmental as an environmental variable. So gcloud IAM service account list, and from that you get the email ID. So you can set that as a service account email, and then you need to add this role to the service account. So every service account will have a role. So the roles are what we need to add. Again, the project. So gcloud projects add IAM policy binding. This is a command which will be used. Here, if you see role, we should use the role. There are various roles available in IAM. So the role here is an SQL client role that we want to give. So that because you're a client, your WordPress is a client accessing the MySQL DB. So you need to have a client role. And then a member with the service account. This is where you are binding your role and the service account ID that we created above. So now your service account ID is this ID, which is provided directly your email, and also your role. You are assigning the role as client SQL client, as a SQL client. And then you are going to create a key for the service account. So service account IAM service account keys create, and then you are linking your IAM account. So with this, you're done with the service account key. So this key is what is important, and this key is what will be used in the code. So this keys.json is what is a secret for you. So you need to store it somewhere. Generally, again, another Kubernetes object, which is again Kubernetes specific, is something called Kubernetes secret that is available. So you can use secrets, Kubernetes secrets, to show your DB secrets. So here Kubernetes creates secret generic, and also your of course the name of the secret, and then your username and your password. So these two things we will store. Basically, the important thing is this password is something which we don't want to expose it outside. So you are setting this password as a secret inside Kubernetes secrets. So then at this point you're creating a secret, and this from literal is what is used as this is all key value pairs in Kubernetes. They all use a column called from literal. So from literal user key and value, key and value. So further use from literal. And Kubernetes secret is where you are actually creating a secret from this file. So there are create secret generic cloud instance. So same thing, more or less, it's the same thing. So here DB credentials and here is instance credentials. So that's the difference. I mean, you need two things. I mean, logically, if you see the steps, there are you are basically in this is something some cloud that we need to learn some of the good practices. So in IAM side, right? I mean, there's nothing to do with Kubernetes. I'm just telling some good practices in cloud. So in cloud, so you need to have two things. One is your DB credentials. Of course, you need to have DB credentials to access the DB, and this is sensitive information. And also, you need to have an application user ID. I mean, application user ID is nothing but your instance user ID. I mean, the cloud term is called as instance user ID. So this is also a good practice to use, so that when instance user IDs or when instance is deleted, your instance user ID is deleted. So this is what is called service account. It's the concept is same even in Azure or AWS. Every instance will have a service account. So it is more or less similar to application ID, but it's more of it's not application. It's called instance user ID. So it's not application. I mean, it's for a familiarity, I told it is application user ID, but it's more instance user ID. So instance user ID and this credentials. So these DB credentials. So password. So these are two things. Service account password. So these are two things which are sensitive information. So which has to be stored in secrets. So the secrets is this is in Kubernetes specific. It's for Kubernetes secrets. The Kubernetes secrets is something which uses the base64 encoding. It's not a super secret mechanism. It follows simple base64 encoding only. But again, if you need an advanced security, then you can add some custom on top. But the basic comes with base64 encoding only in Kubernetes secrets. So which means all the sensitive information like the DB password and your service account password has to be stored here. So that is what we did in the above steps. You see here, we finally executed two secret commands: create secret, create secret. One is for DB credentials and one is for instance credentials. So we stored DB credentials and instance credentials. Instance credentials we got in key.json, and DB credentials we got it when we created the MySQL DB. So these are the two things that we finally stored in Kubernetes secrets. Okay. So let's see if this DB is created. Yes, this is created. So now what we got is a MySQL DB which got created in US Central, and these are the primary addresses. So we can see the same thing from UI also. So you can go to your Kubernetes specific, it's outside Kubernetes. So we can go outside and go to the DB section. Database section. Okay, so here this will have your WordPress. So here a WordPress MySQL is created. So again, this Cloud SQL is a product within GCP which is offering all the relational databases So MySQL, Postgres, and SQL Server. These are three things that are available in the same product, one product, which is Cloud SQL. So yes, so now here we use the MySQL instance, and these are this IP address. So that's what got created now. So we created a DB in cloud now. Let's go and execute whatever we learned so far. So I think we created, we created this command. Yeah, we created this command. Now let's start from here. Let's add the instance connection name. Copy it correct. Okay, so this is creating the instance connection name. I mean, just for you to understand, you can also use this command. Um, SQL instances, and here we need to give an instance name, which is in our case MySQL instance. I'm just showing what are the instances described. Sorry. Showing the describe command here. So if you look at it, it's giving all the metadata about your DB that got created. So here what we need especially is your connection name. So that is what is of interest. So connection name. Yeah. Yeah, this one. So MySQL instance name. So this is a connection name that we took from here. So yeah, so it will be used here for this command. So we'll just run. Yeah, we ran that. So let's run this now. Created it. Now we just create a MySQL, but let's create a DB in this. So this will create a database called WordPress inside this MySQL. So run. So if you see here, you can go here inside this MySQL DB, which got created. Because you can do the same thing going to the databases also, and then you can create the database. So this is monitoring you the CPU utilization and other stuff. So where you can look at what is your IP address to connect to this database, your connection details. If you want to connect it from your local laptop from any MySQL client editor, you can use this connection details. This is a public IP, and this is the configuration stuff. Yeah, service account. You can here also this is creates a service account. Yeah, so you can get all the details here. So connections. So created DB here called DB name is WordPress. So the connections are here which you can use here. Basic information about the certificates and other stuff also you can get it here. The DBs, created database now. So we can also create the database from here. But the WordPress database is what created now. So I'm using command line, so that you can also see what you can create from here also. Create DB and then do the name here. Let's move on. So let's users. So the next step is to create a user. So I think users will not be there. Only the root is there. Let's create a user here. So here we're first getting, we're looking at OpenSSL random base64 command. We want to generate a random password. So for example, we just want to show you this. If I run this OpenSSL command, OpenSSL is a base64 random keyword that it generates. Just generate some keywords like this. So it's a basically for password, that random password that it generates. So yeah, so that's what we're creating a sample password, and then we're associating that here. So let's do the same command. So at this point we're creating a user in the Postgres. Let's see that the user is created here. So okay, so WordPress is created. For example, the username that we created is WordPress. So yeah, we created a WordPress, and then of course we create username as WordPress and password as the random generated password. So now we are done with the DB setup in MySQL is done. So now we are moving to WordPress. For WordPress, we are going to use so the high-level logical steps are same. So we are going to create first the IAM steps, like we create a service account and the secrets. So those steps first. So we already discussed. I'm just moving on. So IAM service account create. So we will create a service account now with the name as Cloud SQL Proxy. So that's the service account name, and also we create the service account email ID from this service account list. So that we can use this email ID as our key. So it's done, and now we can use this Cloud SQL client role. The process steps are first you need to create a service account, and then you should associate a role to the client, to the account. Sorry. So you use that role, this role as Cloud SQL client. Then these are all nothing specific to Kubernetes, and just give some idea of how to create DB in cloud or steps in the ways to handle set up an application in cloud. So this is create a service account. So you see here it listed the various IAM policies. So this Cloud SQL account is what we created. So what we wrote is an add IAM binding policy, and the role is this, and to the email ID is the service account email ID that got created in the poster. So yeah, at this point it is telling the role, and this is C tag, and also the various this binding. There are a lot of members that are also there, so all these members will also have access to this. So let's move on. Step here. For this and we're done with this step. So let's see. So let's move on to the next step, which is creating a key. Okay, so at this point, a JSON is created. So with all my details, the service account details are all stored in key.json. Okay, so let's open this key.json. So this is the service account details that we got created. If you look at the service account is this, project ID is this, and the private key is this, and the private key in an encrypted format is this, and which author, token, URI, and our provider. So X509 certificates are all created. So it's a secure way of handling your certificates and also your authentication using IAM. So now at this point we have created the service accounts, and this file got generated in this step. So now let's also create the service account using this key. So let's create a key. I think the step that behind. Sorry. Yeah. Okay, so we run that step. Now now this was the second, we are back to Kubernetes secret. So far we created all the DB credentials and also instance credentials. We are going to create them as secrets. So we're done with the Kubernetes and the credentials side. We are done. IAM specific we are at tick mark now. Now let's create a WordPress. So WordPress the WordPress uh, is generally, we discussed that WordPress container is what we need, and WordPress Cloud SQL YAML is what is used. So let's open this Cloud SQL YAML. Yeah, so YAML template is what is used. So I'm just opening YAML, Cloud SQL YAML. Yeah, you see here the even though we're going to create a deployment, Kubernetes deployment, because this is like a UI component, right? So UI component has to be deployed using Kubernetes deployment. So we remember it. For anything to deploy a component in GCP, in Kubernetes, so we need two things: one is deployment, and another one is service. So let's deployment will have the container details. The container details is where you are telling the WordPress. So WordPress is a standard image that we get in this that this what is it? In this container image. What's it called? I forgot the name of this. Uh, you have Docker image, sorry. So the Docker Hub. So in the Docker Hub, Docker Hub is what we have a standard image for WordPress. For example, this is Docker registry. From Docker registry, we can directly take this WordPress image. So Docker full WordPress, it will download you the official WordPress UI image from Docker Hub. So we can use that. So that is what is used here in this Docker image, for example. So here the container image is the standard WordPress Docker image that we get, and of course some of the important things that to note. Some of the new things that we need to learn here are anything in DB we need to pass environmental variables. Again, on some of the 12 factor rules, right? One of the 12 factor rules, good practices, is to all the environmental variables should be outside, not inside the code. It should be outside, configured as environmental variables. So following that good practices, so your DB is something which is an configurable stuff. It should be outside, not inside the code. So again, as per the good practice, we insert the environmental variables that we use, which is a WordPress DB host, which is this will be a local container. So that's why we're using the local host 127.0.0.1, and the DB is 3306 is the port for MySQL. And of course the DB user. We wanted to get the value. Here it has a value, but here if you see here, we don't have value. But here instead we are telling DB user and DB password. We are giving a reference to take it from secrets. So the secret is something that we create in the previous step. So if you remember here, the secrets that we created in the previous step will give you that details. So the last step, if you see, we have created the Kubernetes secrets. Here, yes, this one. So client DB credentials, instance credentials. So we are telling used to get the data from the secret. This is called secret keyref we should use, and then we should give the name of the secret that we created here. The secret name create secret. The name is this. So we're giving a reference of the secret inside the deployment. So and the key here is username, and the key here is username. So so basically this will fetch the value which is this DB password. Sorry, this DB user. Sorry, to fetch the DB user, not the password. The password is separately here, same DB credentials and values password. So yeah, that's how this is. So this again, this is another Kubernetes specific stuff you need to remember. You can use name value directly if here it is not sensitive information, so that's why we're giving this value here. But if it is value sensitive information, then we should refer it from secrets. Then we should use value from. So value and value from. That's something you need to remember. And also the reference of the secrets is the key ref. Secret. Ref is something we need to use. Reference and from and ref are something you need to remember. So value from and value in the ref, which is the secret key ref or mount volume key ref. We can a lot of places we use this ref. So yeah, here it is secrets. We are referring from secrets. The name is something which is unique. The name is what should be used, and inside this secret, what is the key that you want to refer. So now if you see, we are not hard coding the passwords here, and in this properties file, even any developer or a deployment person also will not know, except the person who created the password. No one will know what is the password. So it's completely hidden. So again, of course, next is the port, which is container 80, and of course the volume mount is where you need to. This another volume mount is what you're really link. Basically, this is where you're linking your external hard disk to your laptop. Once you, I'm just to easily understand, if you when you plug your external hard disk to your laptop, you get a in Windows you get a D drive or E drive, or a new drive will be linked, right? So that is your external. That's a mounted drive. So similar to that, here from the external hard disk, we are asking to link, instead of a D drive, we are asking to link where WHTML. So this is your WordPress persistent storage that you want to link, and the WordPress persistent storage that we're going to create now. Then so basically that's why you're linking your volume to this container. And then next, that's about the WordPress site. This is an array, so we can have multiple images here. The next image is we are also using the Cloud SQL proxy. Cloud SQL proxy is primarily for you to connect to the DB. So you need to have a Cloud SQL proxy. Again, this is standard from available in Cloud SQL Docker image from GCR, which is Google Container Registry. Again, it's a Google specific image for connecting to DB. So of course, the command is something that you can also give. When this Docker image is downloaded, you can run this command Cloud SQL proxy, and followed by this connection instance name is this. So here, this instance name that we already created in the previous steps, so that will be used here. And your secrets file key.json is here. So basically, at this point, you are now talking. You're asking this. You're giving connection from your laptop to your MySQL DB. So using Cloud SQL proxy. And security context, you're giving inputs like run as user, which means a non-root user, and allow privilege escalation as false. So in case something happens, it will not allow the privilege escalation. So again, this is security stuff. Again, from you can tell run as user is a command which in Kubernetes again to tell whether you want to run this as a root user or a non-root user. Generally, for all applications that runs in, it's always good to use a non-root user so that you're not giving extra privileges to that. So that's why it is good to use a non-root user. So if a root user, then he has complete the superpower. So then it is not a good practice to give a superpower to a security aspect. So you use the two. And again, here we are asking to use the secrets Cloud SQL from this Cloud SQL instance credentials. So that's about this, and also the third thing is the volume. So volume here, if you look at the volume, is the name for Cloud Persistent Storage. If you see here, we created the volume here, so that will reference here. So here is actually we are creating a persistent volume claim. We created a persistent volume claim here, which is now, if you remember, the status was bound. So now we are referring that this is where you are actually linking the request that you made, which is now hard disk is ready with this command, with this storage, but you need to link that to a laptop, right? That linking is happening here. So here you are linking the claim that you created earlier in this previous step. So this is where you are linking as a volume. And of course, the secrets credentials are also stored here. So cloud instance credentials. So this is the volume mount that you created here. So yeah. So summary here at a high level. I mean, this. I'm sure it will be clear for you because it's all. I think it's all pure WordPress specific. And your environmental variables. So it is very common. But what will be very new for you probably is this security as a context, because this is when you want to run something which is Cloud SQL proxy, which is an utility that will run. It will use your key.json, which service account will be used here, and also your security context information, and also volume mounts. Volume mounts are basically your telling where the two volumes that are created here. One is the volume which is related to your secrets, and your volume related to the volume claim that you created here, which is also linked here. So these two things that you are linking here. So let's go back to our steps. So let's come here and let's create. So if you look at well, let's read out this. So this YAML now describes a deployment. It creates a single pod running container with a WordPress instance. These are the WordPress images used, and also container reads a WordPress DB password that is also available in the credentials that we created, the secret that we created here in this step. So DB credentials is from there. The password is fetched. Manifest also configures the WordPress container to communicate with MySQL through Cloud SQL proxy, running a sidecar container. Yeah, I mean, sorry, I didn't give you that background why this Cloud SQL container is required. So this is nothing but this Cloud SQL container is again not very common, but it is used in typical container world of doing it. So we need to create a proxy for UI to talk to DB. So WordPress container is a one container. I mean, I'll just give you some context why it is required. So WordPress is a container, and you have this a container, and there's something called MySQL is a container. MySQL is not in the containers, but it's actually created outside Kubernetes. So we saw that we created this ECP outside Kubernetes. But for these two guys to talk to each other, this guy is inside a container, and this guy is outside container, outside Kubernetes in fact. Container inside Kubernetes. And this guy is outside, MySQL is outside Kubernetes. So for these two guys to talk to each other, Kubernetes and outside Kubernetes, we need a mediator in between. So this is called as a utility, which is also called as a sidecar container. Again, this is a pattern, a design pattern, which is in fact the sidecar container is a design pattern, which is most is used in this Kubernetes and Docker world. So sidecar container is nothing generally a design pattern which is used to do the life cycle processes. For example, you have startup process, or you have a monitoring process, or some utility process, which should run continuously when the main container is running. You also want to gather some monitoring. For example, take this example. So you have container WordPress is running, but you want to get the health parameters of this WordPress. So then there could be an utility component which is acting as sidecar container, which can read the health parameters from the WordPress. So it's a similar concept. So here utility is a which connects these two guys. So this what this utility does is it links to the WordPress and MySQL. It connects these two. So it creates a proxy between these two so that it is inside a container and this is outside the container. So you need to have someone who connects these two guys as a proxy. So you need to have proxy in between. So the proxy is the utility that is this example that we saw here. So this CloudSQL proxy is a proxy which connects your which connects. It's another image at the end. It's a Docker container image. So it is basically connecting your DB. Whatever call that comes from your WordPress, it will go to this proxy, and proxy will redirect the connection to the MySQL DB. So that is what this is for. So and the host address in this is set to WordPress, the WordPress DB host. So that is what we saw here. The WordPress DB host is what we set here as the connection details. So let's move on. Yeah. So let's run this command first. And I'm running. Basically, at this point, we from template we took all this and we substituted the environmental variables with the values to from this. So basically, we replaced the template. It's more of this another way of handling things, where you want to replace the values with the real values. Instance connection name, for example, if you see here, instance connection name is what is used here. But this instance connection name is something is not defined in this, right? We created outside in the previous step instance connection, which is one of the variable that we created instance connection. This is an export variable which is outside environmental variable. So we are using an environmental variable inside dynamically inside your inside the YAML file. That's why it's called as template, and we are replacing the template with the actual values dynamically using this command. So this is another good practice to follow. So that way you can store this template and this will work anytime, right? So tomorrow you want to change this for a different DB, you can use this template as is. So these are some good practices to learn from infrastructure perspective. So yeah, so here we are replacing this command is primarily to replace substitutes the environmental variables with the actual values. So let's run this. Already ran this command. Yes, we're done. Now let's create this WordPress. If I see here, the WordPress YAML is will be there. PersistentVolumes. PersistentVolumes. This one. So I count this. So the same thing, whatever we saw here. So mostly everything is similar stuff. I think where we saw that instances command. Yeah, you see here instance command is actually replaced. Instances TCP 306 is now replaced with this value. So it replaced with real Steam Spider. That's our instance ID, and followed by the name instance name is this MySQL WordPress instance. So this is what is now replaced. So this one is replaced with this. So now we have a file ready. So now we replace the environmental variables with actual values, and now we are creating this. So now let's also create a watch. A watch is primarily to monitor the pod process. So if you see it is still container creating, so which means it is still creating. Basically, this process it is downloading the WordPress image and Kubernetes deployment is getting created. So basically at the end of this, when you do a get pods, you should see a WordPress container running, and also this cloud proxy image also running, should be running. Because we gave two containers here. One is a WordPress image, one is this image of WordPress, and one is the image of this proxy. These two images should be pulled. This watch command is primarily to monitor. It will tell you when it is created, it will give you the update. So you don't need to run this every time. Watch will continuously monitor, and as and when it completes it, it will show you the output. So it is continuously monitoring it. So yeah. So while it is creating it, so you should be able to see at the end of it running. So that we ran here. So now it is running. So I'm stopping it. So if I run this, get pod the -l app is WordPress. Now we have WordPress 2 instances of WordPress are running. Uh, right, and then so let's now so we're done with the deployment. Right, and in everything we saw there's a deployment and there's a service. Service is a networking component. So the service adds a load balancer to this now. So we need a load balancer because we need a proper URL to access this UI. So we need to create a service. So for that, it uses an external load balancer. So let's see this WordPress service configuration. Okay, so kind of service and WordPress. Here it is, of course, this is what is important. The type we discussed a lot. So the type should be load balancer, and here it will have the port, the native port and target port, and the protocol. So what is okay? Load balancer is create, but what is the pod it should look for? The pod is the app named WordPress. So in this process we created the app as WordPress here. So this app as WordPress will be used for your reference. So this name is what is used, container name. So it will. I mean, there will be multiple. The service components are generally one service, but there will be multiple projects will be using the same service. It is possible. So when there are multiple projects are there, so how we will tell load balancer that you need to load balance just my application. So how will you tell that? So that is via selector. So selector will tell you this load balancer should monitor what. So monitor all the containers which are named with WordPress. So when we create the container, we use the name as WordPress. So this will be monitored. So that is important aspect. So let's look at this. Let's create this now. The service is created, but it takes at least 2 minutes to create the service. So let's check the watch on this. So initially status is pending, but once this watch is done, once it is created, you will see some IP, X1 IP here. That's where you can use this IP to connect. And this process, if you look at the port 80 is what is used. That's what we told here to use port 80, and target port is also 80. So this is an internal port, 31343. It's an internal port that will be used for the operating. Yes, so let's see if this picks up. So now we got an IP. I'm stopping the watch. Now I can directly access this website using this command. So of course yeah. So here, if you look at this point, don't do the WordPress installation with the load balancer that expose the cluster. Otherwise, this can set up your website on a cluster. So yeah, continuous effort clean it. Just telling to clean it at the end of it. So now you can go to your browser and directly access this external IP. So just access. So we have a endpoint, static endpoint that can be used to access our website. Cool. So WordPress has come. WordPress redirected to WordPress installations. Yeah, so this is standard WordPress installation. So, of course, there's something specific that we need to do here. For the language, you can set up English, then continue, and so you can standard WordPress that has nothing to do with Kubernetes as such. The WordPress installation page, select the language, we continue, log into information, and click install WordPress login. You enter username and password that you created. So yeah, those things and then you can access it. I mean, there's nothing to do with Kubernetes. I'm just not going inside, but we need to give a lot of inputs and then go inside. But then we have WordPress site running. So I'll just namesake complete this.
Yeah, so long demo, right?
Yeah, a long demo. Yes, yes. I think there are a lot of steps are there in this. But I think this is how you get the flow of end-to-end process. I mean, these are the high-level steps that we involved. Yeah, I'm not going into the details. I
So we
think
showed the complete two-tier architecture, right?
yes. Yeah, these are a two-tier architecture now. So we have a DB setup. We have a WordPress UI component talking to a MySQL DB. I mean, this your details are coming here because it is now actually talking to the DB. Otherwise, you will not get these details also. So let's say if your the WordPress is not talking to the DB, which is MySQL, you're not able to see this information most of it. So which means this communication is happening. It's done.
So what is the thing? Are you going to wind up or anything else to cover today?
Yes, probably I will just touch upon other topic so we get some context what we're going to do next. Um, so yeah, so this one, let's take a look. So this is more.
CSK batting is going. CSK batting is doing good, man.
Okay. Okay, then I will. Maybe want to stop. I will stop it now. Not a problem. So we'll discuss it tomorrow in the next session. What do you guys
In
think?
10 overs, they got more than 100 runs.
Oh, okay. That's very interesting. Yeah, I think this will take just 5 minutes. I think that's logic complete here.
Okay. Yeah, wind up. Yeah, I was just kidding.
Yeah. So yeah, this one, this I think whatever we saw. I mean, just to probably I think it's good to rewind what we just did. So I think logically that will make sense. If you remember here, the high-level steps that we did are because we created the environment. So that's all. I think we just G-cloud the cloud shell specific environment where we told what zone and what project ID and of course we downloaded the code and then we created a GKE cluster. So because Kubernetes cluster itself is not there, so we created that cluster with 3 node setup. And then we requested a volume claim first, and then we requested after the status is bound, which means it is now a volume claim is set up for 200 GB space with the read write on the mode, and then that's all on the Kubernetes side. And then we outside Kubernetes, we created a MySQL using Cloud SQL. So in that we created the logical steps are to create instances, then your DB, of course you create a DB inside that, and then also the passwords. And then we moved to the WordPress site. WordPress site before that we created service accounts first and secrets. So the service accounts create and then of course associate an email ID, and then we associate a role, and then we created a service account using this key, and then we got this key.json. So this key.json is where you have the service account key information, which is sensitive information, so which has to be stored in the secrets. So that's where we use this command to store this key.json. And of course, the DB password is also sensitive information, so we store that also in the secrets. So one important thing is this is something which is weird when compared to others. So this generic is there, which is an extra here in Kubernetes create secret. So Kubernetes create secret, generic, and then the name of the secret. There's something very unique in the Kubernetes side. So yeah, then this Kubernetes. So we're done with the secrets. We stored all the secrets in Kubernetes. Now we now again back to Kubernetes where we want to create the UI component. So the UI component and backend component. So for that we need deployment and a service. So that the deployment is where you are replacing your environmental variables. So thus we create template, and from template you replace with actuals, and then you create a dynamic YAML file. And in the YAML file we created a WordPress component, and also there is a service component is also there, and then we create a service component, and then we access the UI and service. I mean, based on the URL that we get from service. So and then we looked at this step. So primarily three things: volume claim, read write 200 GB, and template. Here the WordPress container image we downloaded. We configured the external stuff as environmental variables, and the volume mounts is this www.html, and then Cloud SQL proxy, which talks to UI and DB. So that is there, and also we also saved the volumes to that. So and then here we use the volume here, and also another reference concept is this values, the passwords, which is sensitive information. We use value from secret key ref. So this is again specific to referencing another Kubernetes object into another Kubernetes object. I mean, the deployment is a Kubernetes object here that we're creating. Inside a Kubernetes deployment object, secret is another deployment object. We are inferring or embedding that like this. So this is another Kubernetes object, secrets, and this is a deployment is another Kubernetes object. So we are embedding secrets objects inside a deployment object, and for that we use ref. Right, and then that's all right. I think nothing much. So this again services we need a load balancer, exporting and porting. That's all. So that creates this end of this step. Yeah. And now at the end of it, you have a fancy WordPress site created. So you can now log in to your WordPress site, and then you can create a blog for you. Okay. So this internally, it is all creating, storing this stuff in a backend, which is MySQL. So we got a WordPress site hosted on GCP. So, yeah, that's where you can access the blog, you create a blog, do whatever, typical WordPress stuff. So, yeah. Anything? I think let's move on to this section. So, any questions here before we move to this? Yeah, I think I'll quickly delete this also, so that way you also know what are the delete steps here involved. So, of course, whenever you're done, I mean, the billing roles, right? So, there's the billing associated with this. So want to delete everything, we have something to Kubernetes delete service. So first, whatever services that we created, we need to delete them. So delete service WordPress. So this will delete, and the service is actually creating a load balancer. That will take some time. But we should wait for the load balancer to be deleted. And then of course you can use this watch command again. Once everything is deleted, you should see listed 0 items. So basically we're asking to list the forwarding rules in load balancer, and also watching it. So it says 0, which means there are no forward rules associated to the load balancer. The load balancer itself got deleted. And then you should also delete the deployment that you created, service and deployment. Right? So service you create deleted, deployment delete. And of course the volumes that you created, PVC volumes, that also has to be deleted. and of course your GKE cluster also has to be deleted, and this Cloud SQL MySQL DB that also has to be deleted. And then of course the roles for service accounts, and then the service account itself. So these are things that you will do for cleanup. This was 0, which is good, means everything is deleted. Then we delete the deployment, deleted, all the PVC thing, deleted, cluster is deleted. This may take some time. Any questions in this? Yes, no, we've done many things here in this, but I think it was a good learning in terms of how to create a modern web application. I already read it better. So yeah, let's move on to this. I think we just need 5 minutes or so. So this tutorial demonstrates how to create a cloud service account and assign roles to the cloud services and use the cloud account credentials in applications running in GKE. So again, this is nothing specific to. I mean, it's more about how to use secrets and service accounts. I think we already saw it in the previous session, but here this will give more emphasis on that. The security is one of the important aspects that we need to consider. So it is good practice to use secrets wherever possible, and TCP has a lot of secret specific stuff which are available, starting from service account to secrets, Kubernetes secrets that we also saw in the previous session, and also how to use service accounts for an application. So the idea of using the service account is you will use that service account when we use that. I mean, just to see the last session, right? I think remember that service account that we created, we use that here. Okay. So this is a utility that is running. This is a container, and this it requires a credential file, and this key is what is used here. So it is basically using the service account that we created, and it is used when it is running on this virtual machine. This image is using this service account. So that's why it is important to use service account as a good practice in the cloud environment. So for that, the service account will be used, and generally it is used in the deployment object. We use this service accounts for especially under the containers that under the containers section. The container section we use this key. Same thing here. The passwords, the secrets that we use also use on the containers. Where are the secrets we need from? So yeah. To answer where you use service accounts, where you use passwords, they are all mostly in the deployment object in Kubernetes under a section of containers, either in the environmental variables, which is for secrets, DB stuff, and for any utilities or sidecar containers that you want to run. So it needs a file, a JSON file, or some format. As the service account will be used because this is running as a sidecar container inside the node. So you need to also have for that to run. You need an authentication and you need a service account, and that is what is used here. So yeah. So this is again. Probably I will go more in this in the next session, but I think what you need to know at a high level for today's, there are a lot of options in GCP, but it's more workload identity is one very common recommended way to use. Again, because I think it's more of a GCP specific, but I think the concept is same to any cloud. The service account is what is the concept. So. And workload identity is a a product within GCP. But what you need to take away is any workload that is running, it requires an identity. That is, there's a newer way of handling security in the cloud. So any workload that is running in a VM, it requires an identity, and so you need to first create that the workload identity using some security mechanisms in cloud, either IAM or in Azure, is Azure AD or whatever. So you need to create a workload identity, which is called service account, and that should be used in Kubernetes resources. So that way, when you are terminating this VM, the service account also will be terminated. So very common problem in security space is that we create a lot of user IDs, but we never delete them, or we forget to delete them. So such issues can be avoided when we use a service account concept. So the service account is tied to that VM only, or to that workload only. So that when we're deleting the workload or when we're deleting the VM, the resources also will be deleted. So that way you need to manage the deletion process. So that is a good practice to be learned from cloud. Yeah. So I think we need to use that, and also we should also use service account. Also, workload identity is one option, or creating the service account from virtual machine is also another option. Again, why use better visibility, auditing, API requests, ability to revoke keys. Revoke keys, like whenever you want to when you're deleting the instance, it is all deleted. Similarly, when you want to revoke some permissions, you can do that from outside. And also reduce exposure in case of potential security incident. So these are things, these are advanced. I will stop here. Probably I will go through this more in the next session. So any questions? Okay.
Yeah, good, man.
Okay. Okay, guys. Thanks a lot. Thanks, everyone. See you next week.
Thanks, man.
Bye-bye.